Today we're going to solve a system with 3 variables. That means we have 3 equations with 3 unknowns. If you look, the top one has an x, y, a z, and a number. The second one only has an x and a y. It just means it's plus 0z. And the third one is x, y, z equals 17. So what I need to do is combine these and figure out what each of the variables would be. My strategy is going to be to try to whittle it down to 2 equations with 2 unknowns, and then use the same strategy that I used in the previous section. So I already have one equation with an x and a y. So my idea is if I can get equations 1 and 3 to combine and get rid of the z's, then I would have equation number 2 with just an x and a y. And then I'd have another equation with x and y because these have been canceled out. So I'm going to try to add together equation 1 plus equation 2 and get my z's to cancel. I'm going to take equation 1 and I'm going to multiply that one by -5 to get -5x plus 10y minus 15z equals -45. I'm going to take equation 2 and multiply by 3 to get 6x minus 15y plus 15z equals 51. I'm going to add those together and my z's cancel. I end up with x minus 5y equals 6. So this equation is a new equation. I'm going to call it equation number 4. And I'm going to add it to equation number 2 because they're both just x, y equations. If you have 2 equations with 2 unknowns, you should be able to add those together, get something to cancel, and actually solve for a letter. This one's set up really nice. I don't have to do any adjusting because my x's will cancel. I have -2y equals 2, divide both sides by -2, and y is -1. Now I need to work backwards to find my other answers. So I'm going to go back to equation 2. I like equation 2 because it only has 2 letters, and I'll plug in y. So -x plus 3 times -1 equals -4. Add 3 to both sides, and x equals 1. Now I need to find z. I can plug it into any equation that has a z in it. I'm going to plug it into equation number 1, and I get x is 1, minus 2 times y is -1, plus 3z. And then I'll solve this one. 1 plus 2 is 3. Subtract 3 from both sides. Divide by 3, and z is 2. I'm going to put my letters in alphabetical order. X is 1, y is -1, z is 2. Now we'll go and try the example on the back. Example on the back is similar to the one on the front. I just don't have my equations written yet. So it says the height at time t of an object moving in a vertical line with constant acceleration is given by this. So I have this equation. I don't know A. I don't know V naught, which is V sub 0, and I don't know S naught. So those are the things I'm trying to find. It says find the values of A, S, V naught, S naught. So that when I'm done, I'm going to have an equation with values filled in there. It gives me some information. It tells me that S is 52 at time equals 1. S is 52 at time equals 2. And S is 20 at time equals 3. Those 3 little bits of information is going to help me write and solve a system. So what I'm going to take for this first bit of information is plug in 52 for S and plug in 1 for each t. So half a 1 squared plus v naught times 1 plus s naught. Do the same thing again, plug in 52 for S, plug in 2 for each t. Half a 2 squared plus v naught 2 plus s naught. And then the last one, it says s is 20. Half a 3 squared plus v naught 3 plus s naught. This is my system. I think we can simplify them, but this is how I took each time and height measurement and plugged them in to get my system. Cleaned up, it's going to be 52 equals half a plus v naught plus s naught. 52 equals 2a plus 2 v naught plus s naught. And 20 equals 9 halves a plus 3 v naught plus s naught. So this is my simplified version of my system, and now I need to solve using the technique I used on the front, which is try to add 2 together to get something to cancel. So I'm going to go for my s naughts to cancel because they all have a coefficient of 1, so I think that'd be the easiest. So I'm going to take equation 1, and I'm going to multiply that by -1, and then I'll add that to equation 2. So equation 1 would be -52 equals -half a minus v naught minus s naught. In equation 2, I'm just going to write the same. And when I add those together, my s naughts cancel. I have 0 equals, this would be 1.5 a plus v naught. So what I wanted to have happen is get one of the variables to cancel. So I have an equation with just an a and a v naught. I'm going to do that again, pick 2 different equations and try to get that same variable to cancel. So next time I'm going to add together 1 with a -1 in front of it and 3. So -52 plus 20 would be -32. -1/2 plus 9 halves would be 8 halves, which is 4a. And v naught plus 3 v naught would be 2 v naught. And then those would cancel. I didn't write those down, I just added them. So that is my system of equations, now getting that s naught to cancel twice. So now I'm left with this. Now I need to get something to cancel by adding these 2 together. And I'm going to try to get my v naughts to cancel by taking this one and multiplying it by -2. So I have 0, -3a minus 2v naught, -32, 4a plus 2v. When I add those together, my v naughts cancel. I have a equals -32, so that's one of my answers. I'm going to go and find an equation that has an a in it and plug this back in. I like this one. So 0 equals 1.5 -32 plus v naught. 1.5 times -32 is -48. So my v naught equals 48. Then I'll take that and plug it into any of my original equations. I'm going to pick equation number 1. 52 equals half times a, which is -32, plus v naught, which is 48, plus s naught. And then I'll try to figure out what s naught is. 52 equals, that's -16, plus the 48. So it's 32 plus s naught. So s naught would be 52 minus 32, which is 20. So I have my 3 answers here, here, and here. My final thing is going to be just to write an equation with those values plugged in. So s equals half times a, which would be -16t squared, plus 48t, plus 20.